Hey guys, welcome to another video where I'll be teaching math. I'm Abhinav. I've done both my bachelor's and master's in electrical engineering from IIT Kharagpur. In today's session, we are diving into an intriguing problem that you see right here on the screen. If you have worked through definite integrals before, prepare yourself because this one is a whole new challenge. Make sure you have your notebooks ready, grab a pen and stay tuned until the end for the full solution. When I first came across this question in a coaching center's material, I was momentarily puzzled. But with some thought and determination, I figured it out. And now I'm here to share the solution with you. So let's jump right in and tackle this together. Do not forget to like, share, and subscribe for more exciting math problems and solutions. So what do we have here? We have a function f of theta which is defined by the summation of sine theta and this particular definite integral, and we are asked to evaluate the value of this definite integral. So if you observe the integral given, so you have f of theta here and the same function f of t goes inside the integral. So such equations are called as integral equations. If your function sits inside the integral and you have the same function outside and it is forming an equation, then those kind of equations are called as integral equations. Let us see how it goes. So you have a function f of theta given by sine theta plus integral minus pi by 2 to pi by 2. If you notice, the parameter is t here. So these limits are going from t is equals to minus pi by 2 to plus pi by 2. So the sine theta and cos theta are independent of this integral. They are as good as constants. So we can bring sine theta out of the integral and this can be written as f of t dt, plus similarly we can bring out cos theta minus pi by 2 to pi by 2 t times f of t dt. Now the thing that you should notice is this is a definite integral and this is one more definite integral, and when you evaluate these integrals they'll give you some constant values. So let us say the value of this integral is a and the value of this particular integral is b. Then we can write f of theta is equals to sine theta plus a sine theta plus b cos theta. That is 1 plus a sine theta plus b cos theta. So this is one equation that we have. We have another equation which is a is equals to integral minus pi by 2 to pi by 2 f of t dt, and we have one more equation which is b is equals to integral minus pi by 2 to pi by 2 t times f of t dt. But now we know what f of t is. So we have f of theta here. If we replace theta with t, we will get f of t. So a is equals to integral minus pi by 2 to pi by 2 1 plus a sine t dt plus integral minus pi by 2 to pi by 2 b times cos t dt. Now if you check, the integral is going from minus pi by 2 to plus pi by 2 and sine t is an odd function. So you have an odd function and your integral is going from minus pi by 2 to pi by 2. So the value of this integral will be 0. And similarly here also the integral is going from minus pi by 2 to pi by 2, but you have an even function inside. So the integral will be b times twice of integral 0 to pi by 2 cos t dt. So the limits will change and the integral will be multiplied by 2. So that is a is equals to 2b, and integral cos theta is sine theta, so this will be sine t limits are pi by 2 to 0, so that is simply a is equal to 2b when you apply the limits. And now let us go to this particular equation. So here we have b is equals to minus pi by 2 to pi by 2 t times f of t is 1 plus a sin t dt plus integral minus pi by 2 to pi by 2 t times b cos t dt. So now if you check this particular integral, cos t is an even function but t is an odd function. Therefore this integral goes, when evaluated, gives you 0. Now let us consider the first integral, that is b is equals to integral minus pi by 2 to pi by 2, 1 plus a comes out since it is a constant, t times sin t dt. Sin t is an odd function and t is also an odd function. So odd function multiplied by an odd function will give you an even function. So therefore we can change the limits from 0 to pi by 2 and multiply the integral with 2. Alright. So now we have to find out this integral. So for that we can apply by parts. So we can consider first function as t and second function as integral sin t, which is minus cos t. So b will be twice of 1 plus a times t times minus cos t. The limits are from 0 to pi by 2 minus integral minus cos t du is dt. So dt. The limits are from 0 to pi by 2. Alright. So now this will be 2 into 1 plus a. When you put t is equal to pi by 2, cos t will become 0. When you put t is equal to 0, t will become 0. So this is 0. So minus into minus is plus. So this particular minus and this particular minus, it will give you plus 0 to pi by 2 cos t dt. Here we have found out what 0 to pi by 2 cos t dt is. So it is simply 1. So this is b is equals to twice of 1 plus a. But from this equation we have a is equals to 2b. So b is equals to 2 times 1 plus 2b. So this is b is equals to 2 plus 4b. This implies minus 3b is equals to 2, b is equals to minus 2 by 3. And from here we get a is equals to minus 4 by 3. Now we have a and b. Now we have to find out the value of this particular integral. Integral 0 to pi by 2 f of theta d theta. So this will be simply integral 0 to pi by 2 1 plus a sin theta. F of theta is 1 plus a sin theta plus b cos theta. So 1 plus a, that is 1 minus 4 by 3 sin theta plus b is minus 2 by 3 cos theta d theta. 1 minus 4 by 3 is minus 1 by 3 minus 1 by 3. Integration of sin theta is minus cos theta. So the limits are from 0 to pi by 2. Minus 2 by 3. Integral cos theta is sin theta. So the limits are from 0 to pi by 2. So this is minus 1 by 3. When you put theta is equal to pi by 2, it will be 0. When you put theta is equal to 0, it will be 1. So this will be plus 1. Minus 2 by 3. When you put theta is equal to pi by 2, it is 1. When you put theta is equal to 0, it is 0. So it is minus 1 by 3 minus 2 by 3. That is simply minus 1. But we are asked to find out the modulus of this particular quantity. So therefore, the answer is 1. So what we have done? So we have identified that these integrals are as good as constants, and we have written the function in terms of those constants, and then we took each constant and we tried to substitute f of t and evaluate the integrals. Alright, this is how you solve the integral equations. If you like the solution, hit that like button, share it with your friends, and subscribe for more such content. See you in the next video. Thank you.